Compressed air is the muscle behind most of the motion on a factory floor. Clamps, grippers, slides, presses, sorting gates. Push on almost any of them and you'll find air doing the work. And the thing that turns that air into real, working force is a pneumatic actuator. So what exactly is one? In this video, I will explain what a pneumatic actuator is in plain terms. Then the two big families, linear cylinders and rotary actuators. How a PLC actually controls one, and where pneumatics win and where they do not. Let us start with the idea. Quick note before we dig in. This is from PLC Simulator, where you can practice automation and PLC control free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now back to the air. Here is the whole concept in one line. A pneumatic actuator converts compressed air pressure into mechanical motion. Feed it air and it pushes, pulls, or turns. That is it. The air is stored energy. The actuator releases that energy as movement and force. Why air? Because it is cheap, it is fast, and it is simple. You compress it once, pipe it around the plant, and tap it wherever you need motion. And it is clean, no oil leaking onto your product. So anywhere motion needs to be quick, repeatable, and uncomplicated, a pneumatic actuator is usually the first tool reached for. The most common type is linear. A pneumatic cylinder. Picture a piston inside a sealed tube. Push air in behind the piston and the rod strokes out. That straight push and pull is what clamps apart, pushes a box, or presses a stamp. Now, there are two flavors. A single-acting cylinder uses air to extend and a spring to return. Cut the air and the spring pulls it home, which makes it a natural fail-safe, parking the rod in a known position. A double-acting cylinder is different. It feeds air to either side of the piston, so you drive it out with full force and drive it back with full force. Most industrial motion uses double-acting because you control both directions with power, not a spring. Not everything moves in a straight line. That is where rotary pneumatic actuators come in. Instead of stroke, they turn air into rotation. One common design is rack-and-pinion. A piston strokes a toothed rack. The rack spins a pinion gear, and the output shaft rotates. Another is the vane type, where air pushes a vane around inside a chamber to make it turn. The classic job for a rotary actuator is opening and closing a process valve, a quarter turn, on or off. So whenever you see a big valve flip automatically on a pipe, a rotary pneumatic actuator is often what flipped it. So how does the PLC actually move one? A pneumatic actuator does not steer itself. The air has to be routed to the right port at the right moment. That job belongs to a directional control valve, a spool valve. The spool slides inside the valve body and decides which port gets air and which port vents. To shift that spool, the valve has a solenoid. A PLC digital output energizes the solenoid. The spool moves and the cylinder strokes. I cover the spool valve itself in a separate video, linked below. One more piece. Before the air reaches any of this, it passes through an FRL, a filter, a regulator, and a lubricator. That cleans the air, sets the pressure, and protects the seals. So why reach for pneumatics at all? For reasons. They are fast. Air moves quickly. They are cheap. The actuators and valves cost little. They are simple, fewer parts to fail. And they are safe in hazardous or washdown areas because there is no electrical spark at the actuator itself. But there is a trade-off. Air is compressible. It springs a little under load. So a pneumatic actuator is less precise and less stiff than an electric servo. And it really wants the two end positions, not a held mid-stroke. You also need a compressed air supply feeding it. Pneumatics are just one branch of the wider actuator family. Electric and hydraulic are the others. I cover the whole picture in the linked actuator overview. So here's what to walk away with. A pneumatic actuator converts compressed air into motion. Linear cylinders push and pull, single-acting with a spring return, double-acting with air both ways. Rotary actuators turn, using rack-and-pinion or a vane. A spool valve routes the air. A PLC output fires the solenoid, and an FRL preps the air first. Get that, and every air cylinder on the floor stops being a mystery. Now, go make it concrete. If you want to practice automation hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.